Hello and welcome to Dr. T's Math. In this video I'm going to look at some probability and statistics problems with permutations, combinations, and factorials using the TI-84 emulator. Our first question here, very similar to something you might see on the ACT or another standardized test. A car manufacturer offers 4 paint colors, 3 interiors, 2 sunroof options, and 5 powertrain models. How many different unique cars are available for consumers? This is very similar to the Chinese buffet question or takeout question or different sandwiches where they've got various options for restaurant customers. So you're just going to multiply these. You got 4 paint colors by 3 interiors by 2 sunroof options by 5 powertrain options. So 4 times 3, we don't even need the calculator there, that's 12. 12 times 2 is 24. Then 24 times 5 is 120. So that one was simple enough. How about if you work at a car lot and there's 10 cars, how many ways can you arrange 5 of those cars in front of the sales office? Now, we could draw out a picture. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cars, and you want to take 5 of those cars and put them in front of the sales office, but we could have these 5, or we could have the first 4 and then that one, or we could have the first 4 and then that one. This could get fairly tedious trying to draw out all the different options. And so luckily, we can refer to factorial. You got 10 total cars, and so imagine 10 times 9 times 8 times 7 all the way down to 1. And we're just going to divide that by 10 minus 5, which is 5. And so again, this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Divided by 5 times 4 times 3 times 2 times 1. And that is n factorial over n minus r factorial. And then these cross out and those cross out, so what you're left with is 10 times 8 times 10 times descending order down to 6. But luckily, we don't have to do all that much. We could type in all these things, 10 times 9 times 8 times 7 times 6, and get 30,240 different arrangements of 5 cars in front of the sales office. Now, does order matter? Yeah, basically order matters because each car is unique. And so that order matters is important because we're going to get way more combinations since order matters. So like 1, 2, 3, 4, 5 is a different, distinct arrangement than 5, 4, 3, 2, 1 or 1, 3, 2, 4, 5 or so on. And so we get 30,000, but there's another easier way. Go to math, below alpha, math. And then, first you have to type in the first number, which is 10. So we have 10 possible cars, and go to math and over to probability. And then it's NPR, permutation. Permutation is always going to have more possibilities than combinations. And of those, we're going to choose 5, and we get that same number there. 30,240, that's a lot of possible arrangements of the cars. Next question, you still work at a car lot with 10 cars. How many groups of 5 cars are available of the 10 on the lot? So in this case, we're just looking for groups. And a lot of times the questions on ACT will say there are this many people in a class, and maybe you have to choose some elected officials or something, or you're going to choose some group from that class. And so in this case, here's a group, 1, 2, 3, 4, 5. And whether it's 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, or 1, 3, 2, 4, 5, or 1, 4, 2, 3, 5, or whatever, those are just still the same group, right? We're still choosing just these 5. And so order doesn't matter, which means that we're going to end up with n factorial over n minus r factorial times r factorial, which is, you can see there's an additional element there in the denominator. So there are going to be fewer options available. We're going to get 5, which is 10 minus 5, and then 5 factorial again. And so we could, again, do the expansion here, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 5 times 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And then these are going to cross out there. And we got some common factors we can still cross out. 5 is going to take the 10 down to 2. 3 is going to take, I'll take 9 down to 3. And then 4 is going to take the 8 down to 2. And then 2 is going to take the 6 down to 3. And so what we're left with is 2 times 3 times 2 times 3 times 7, which is 2 times 3 times 2 times 3 is 6 times 6, or 36. 36 times 7. 36 times 7. And I could work that out, but there's not much room there. 36, oops, 36 times 7 is 252. But there is an easier way. Now, to show that these were equal, we could say again, 10, and then factorial is there in math again, probability, number 4 factorial. And then we're going to divide that by 5 factorial and 5 factorial again. And indeed, that's 252, but there's still an easier way, or a faster way. 10 choose 5 is going to give us 252. So there are 252 possible groups that we could take of those 10 cars to display in the showroom or in front of the showroom or whatever. Oftentimes you'll see a number of cars in the showroom at a car dealership, and indeed they have way more than 10 cars, so you can imagine the number of possible combinations. If they had hundreds of cars on the lot, well, this is increased by quite a lot. So 252 there compared to 30,240 there. So you can see if order matters, it increases the number of possible arrangements by quite a lot. Okay, this has been Dr. T's Math. Thanks for watching.